I'm Tim Ventura, and we're joined today by Dr. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University. Avi is a theoretical physicist who works on astrophysics and cosmology, formerly the longest-serving chair of Harvard's Department of Astronomy, the founding director of Harvard's Black Hole Initiative, and director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. Among his many achievements, Avi is a best-selling author, has published over 700 papers and essays, made major contributions to scientific topics, including black holes and gravitational microlensing, and received recognition and awards from dozens of prestigious scientific organizations and academic institutions. So, Avi, welcome back. It is a pleasure, as always, to have you with me, sir.
My pleasure to join you. It's my privilege.
Well, so today we are talking about your new book, Interstellar, The Search for Extraterrestrial Life and Our Future in the Stars. And actually, you have a copy of that there. If you could hold that up. You sent me a copy as well. I have read the book twice. It is absolutely amazing. Absolutely amazing. I would call it a tour de force of space science that combines personal history, scientific discovery, and speculative futurism into really what's a blueprint for humanity's future in space. So what inspired you to write this book, and how long did it take to complete this?
What triggered this book is the discovery of the first interstellar object that came from outside the solar system by scientists. The first one was actually noticed by the US government satellites back in 2014, and it was a meteor, an object the size of half a meter that collided with Earth and was moving very fast, faster than the speed necessary for it to escape from the sun's pull of gravity. And that led us to infer that it's interstellar in origin, a proposition that was supported by the US Space Command in a formal letter to NASA back a year and a half ago. And I led an expedition to retrieve the materials from this meteor, the first one from interstellar space, just in summer 2023. And obviously, my book came out with a punchline, which is interstellar. This object is definitely interstellar, not just because of its speed, but because its material composition was different than any material that we find within the solar system, like the rocks on Earth, the Moon, Mars, asteroids. And that implies that it came from a completely different environment. And the fundamental question is whether it was natural in origin, which is a possibility, or technological in origin, which is also a possibility given that it was moving faster than 95% of all stars in the vicinity of the sun relative to the local frame of the galaxy. And also that it had material strength tougher than all space rocks we had seen before over the past decade in the NASA catalog from the solar system. So obviously, that is the key question, and we plan a follow-up expedition to look for any big pieces of this object to figure out whether it was a rock or a technological gadget. And after that, there was Oumuamua, an object much bigger, the size of a football field, that was discovered in 2017. And it also had anomalies. It was flat in its shape and was pushed away from the sun by some mysterious force without showing cometary evaporation and the rocket effect that you expect to occur in that case. And so the question was, what pushes it? And I suggested that it's the sunlight. And for that, the object had to be very thin, and nature doesn't make such thin objects. So I was intrigued by the fact that the first two interstellar objects appear unlike the rocks we had seen before in the solar system. Just like going out to your backyard and you find a tennis ball thrown by a neighbor, you ask, well, it doesn't look like the rocks I'm used to. What does it mean? Do I have a neighbor? And that is the kind of question that I started asking myself. And by the way, it's not a matter of opinion, because we can conduct scientific research right now into this question, which is what I'm doing. I think it deserves to be center stage within the mainstream of astronomy, because it's a completely new way to learn what lies outside the solar system. Rather than looking through telescopes, we are looking through microscopes in the case of the meteor fragments. And it's exciting because it's like a detective story. Let's figure out whether there is space trash out there that is technological in origin, because the implications for humanity would be huge. So that is what my book focuses on. How would it affect us here on this rock that we call our home, the Earth? And how will it change our plans for the future?
Well, Interstellar follows on the heels of your New York Times bestseller, Extraterrestrial, the first sign of intelligent life beyond Earth, which you published back in 2021, so only a couple of years ago. And I've noticed that both of these books discuss many shared topics, but they approach them from different perspectives. And obviously, you have the benefit of 2 years of additional research and, exploration, I guess, in the new book, Interstellar. I'm wondering if it's worth recommending that people start with your book, Extraterrestrial, to fully understand the evolution and progression of your research over time, to then put it into the context of the book, Interstellar.
Definitely, because one additional aspect, in addition to having Oumuamua known when I wrote my first book, is that we now know about this meteor that I mentioned that was 4 years earlier. But in addition to that, there were discussions in the US Senate and Congress about those unidentified anomalous phenomena. And that is a subject of great interest, because it's possible that the US government may have some data on materials that were retrieved, or information about the unidentified objects that could be from outside of this Earth. And that was discussed in the House of Representatives just this summer. And that brings the discussion to a different level, because the objects of Oumuamua, or the meteor, did not seem to be functional devices. They were not spying on what's happening here on Earth. Whereas those objects that the US government talks about, they appear to be functional devices. The question is whether they're human-made or something else. And obviously, there are two types of objects, space trash and functional devices. And the functional devices are more interesting because they can teach us more about the sender based on what they're seeking, what information, and what is their task, basically, the intent. And so we have to wait and see if the government discloses anything, but the sky is not classified and the oceans are not classified. So there is a lot of room for scientists to get engaged and figure out if there is anything unusual out there. And my book, the new book, Interstellar, is examining the Galileo Project that I established at Harvard University, and which is part of this scientific inquiry as to the nature of unidentified anomalous phenomena. So that's a completely new layer of research. And also by now we have the expedition that happened, and so that's another perspective on interstellar objects that we gained over the past 2 years.
Well, in Interstellar, one of the things that I truly love about this book is that you do tackle the UAP phenomena head on, right? That's not something that you're avoiding in any way. And you're building a bridge between today's debate about the potential extraterrestrial origin of UAP and tomorrow's challenge of what to do next, right? Where do things go from here? In a sense, this is something that you've been thinking about since Oumuamua back in 2017, right?
Right. Yes, definitely. You may think of discovery of a neighbor as a wake-up call for us to change our priorities, because if someone else reached our doorstep, we might want to reach their doorstep with our own devices. We might want to learn from their technologies, because that's a peek at our technological future. And maybe if they were more advanced than we are, we can learn something new about science and technology from that. So altogether, it's a learning experience, and it's inspiring for us to explore space. And therefore, I think it will be of great benefit to us humans to not only learn whether we have a neighbor, but also learn from our neighbor and be inspired. Because as of now, we're investing a lot of effort in conflicts on this rock that we call Earth. And it's about time that we change priorities and start to explore space. There is much more real estate out there. And we are all in the same boat, which is the Earth sailing through space. And we should work together towards the longer term future and think about those issues of our existence on Earth and where do we go from here. And we need to imagine going to many other places way beyond the solar system.
Now, earlier this year, you co-authored a paper that touched on UAP, Oumuamua, and space science with Aero director Sean Kirkpatrick, entitled Physical Constraints on Unidentified Aerial Phenomena. In that paper, you both speculated that all three of these topics could potentially be connected. Do you feel there's a strong possibility for that still, given the anomalous nature and timing of all of these events?
It's possible, but first, if we want to associate the UAP, unidentified anomalous phenomena, with any interstellar object, we need first to verify that they are out there, that indeed there are technological gadgets not made by humans, and then we can ask, are they causally related? If a bigger mothership came by and spread them like seeds on the planets in the inner solar system, that would be quite interesting. If the journey took millions or billions of years, the senders did not have us in mind. They didn't know that we exist because humans came to Earth only over the past few million years. And so in a way, they had a task. They were programmed to do something, and it would be interesting to figure out what that program was. You can think of these as shadows of the senders, and it's just like in the cave allegory of Plato, where we just look at the shadows and try to figure out what makes those shadows. In this case, we look at the packages that arrived at our doorstep and try to figure out who sent them. There may be a postal address if we land on one of them or analyze a crash site. But other than that, it's a matter of figuring out what the intent was. And it's just a fascinating detective story. If the gadgets are intelligent, if they have artificial intelligence, I think one should trust the psychologists more than physicists, because they are used to dealing with intelligent beings, humans. But if it's a very sophisticated artificial intelligence, we might use our own AI systems to figure out their AI systems.
Well, and I definitely want to come back to the AI part of this, because again, in the book Interstellar, that is a large part of what you'd written about. But in terms of Oumuamua, the debate about Oumuamua seems to be whether this was an alien spacecraft, perhaps a mothership, as yourself and Dr. Kirkpatrick had speculated, or instead maybe just an interstellar rock on an unusual trajectory. Now, the interesting thing from my perspective was I recently did an interview on space radiation, and the person that I spoke with had suggested that hollowed out asteroids might be preferable for use as interstellar vehicles because of the natural shielding they provide. So I'm wondering if both sides of this debate could actually be correct.
Yeah, in principle, it could be. I mean, humans used caves early on in our history. And we might go back to using caves when we go to Mars, because that offers shelter against cosmic rays and the variations in temperature on the surface of Mars. So you can imagine expanding this idea to rocks that are hollow and have something going on inside of them. But in principle, a technological civilization doesn't need a rock to create a shield. They would build a spacecraft that has a shield. Now, the advantage of having a facade of a rock, something that looks like a rock, is that they can enter planetary systems with nobody suspecting that they are not natural. So that may be a reason to do it, actually. It's sort of like a Trojan horse. entering the system, but having a lot of soldiers inside. That's a possibility. We should be open-minded to whatever nature the visitors have, because our imagination is limited to our experience here on Earth. And nature is often much more imaginative than we are. So the first thing to do is basically rule out, if we see an unusual object, rule out the possibility that it's a rock, a natural object. And then if it looks like it's technological, just rule out the possibility that it was made by humans, which should be possible if you have enough data on it.
Well, I want to remind the audience also about your recent trip, your recent expedition to recover interstellar meteor fragments from the Pacific Ocean. And you had predicted that was interstellar in origin. You've done the metallurgical analysis on it, which seems to confirm that. So, so far, I would call that a giant victory for science. And I think it also seems to support all of these hypotheses as well. Does that have any implications for the other work that you're currently involved in?
Yeah, because we found a composition that is not represented by rocks within the solar system. And the question is whether it's indeed a rock from another star system or perhaps a technological object. And of course, the way to tell is by finding bigger pieces. But it's, as you alluded to, it's a historic step forward in the sense that it's the first time that scientists analyzed materials of a large object, in this case, 0.5 meter in size, roughly the size of Voyager spacecraft in order of magnitude. And that was never done before. So even if it's natural, we will learn something new about environments that make those interstellar objects. And you need a lot of them. Just for one of them to collide with Earth every decade, you need millions of them within the orbit of the Earth around the sun at any given time. And altogether, for each star in the Milky Way galaxy, you need 10 to the power 23 of them to get a large enough population such that one of them will collide with Earth every decade. That's a large number. The mass of this object was nearly a ton. And if you take a ton worth of mass, multiply by 10 to the power 23 such objects per star, you end up with an Earth mass. So basically, you need to break up a planet as big as the Earth into pieces that will have the kind of composition that we are talking about, that we found for every star in the Milky Way galaxy, which sounds challenging, but maybe it's possible. It's something I'm looking into right now.
Now, towards the end of the book, you delve deeply into the role of machines in exploring the galaxy. And this is something that I'm incredibly excited and passionate about myself. You've described them as AI astronauts on many occasions. I'm wondering if you view this as an evolutionary progression where today's Mars rover might become tomorrow's AI explorer, and the day after that may create new versions of itself to explore further out as some kind of von Neumann probe.
Yes, exactly. So the Mars rover and the Ingenuity helicopter are being managed by engineers in the Jet Propulsion Lab in Pasadena. And those NASA engineers are just like helicopter parents. They are actually parenting the helicopter on Mars. So that is not the way to go when you deal with interstellar travel, because it takes light thousands of years to traverse the Milky Way galaxy. So you can't have the probe waiting for guidance from the senders. And also, it's very difficult to transmit information across those vast distances. So the probe needs to be autonomous, having a brain of its own, and that's what AI can do for it. So AI astronauts are basically systems that are autonomous. They do not need the senders to tell them what to do. Sort of like kids after they mature and become adults. And the advantage is also they can go through the huge amount of data that they encounter and they only send back messages that are really important. But other than that, they will figure out what the data means as to their daily operations. And moreover, they can potentially reproduce themselves. if they have 3D printing capabilities and so forth. So I do think that's the wave of the future. So far, AI was not sent to space, but I do think that in the coming decade, it will be an integral part of sending probes to space. And I'm actually working on it right now myself, creating an initiative that will launch systems with AI to space. I think that is the future. And for other civilizations, it may have been the past. That is an inspiration that we can get when we encounter intelligent probes visiting us.
Well, again, I want to recommend that everyone in the audience buy a copy of Interstellar and read this book. There are so many exciting things in this. Towards the end part of the book, you start to get into connecting UAP with SETI, but also with a technological singularity. And there are many notable scientists, including people like Professor Martin Rees, who I recently interviewed, who have speculated that machine intelligence is the natural endpoint for all advanced civilizations. So do you think this could offer insights potentially into the UAP phenomena, perhaps as well as the great filter resolution for the Fermi paradox?
That's possible. I'm not sure it's the end of humans. However, it is an important phase transition for us, these large language models. And I asked the psychologist, what made us different when we deviated from chimpanzees? And the answer was, it's the language, the fact that we use language that is so rich. And obviously, language is also leading us to the next milestone, which is these large language models taking our place on many aspects of our daily lives. And ChatGPT 5 may actually have more connections than the number of synapses in the human brain. And as a result, it would be a more complicated machine than the human brain. And that is definitely a phase transition. And we need to think about what the future might hold in terms of what makes us human and why we maintain some territory that the machines can help us do things, but we still have the ambitions and the inspiration that drives our future for us to decide about. And so I'm not pessimistic about our future. I'm very proud of our technological kids, and we should use them in space as well. As to what it leads, that would be something to be seen. And one way to see it is by actually finding other civilizations that went through this transition. And we can examine their accomplishments by monitoring our backyard for any objects that they sent there. And so that is a shortcut towards learning more about them.
Yeah. Yeah. And in the book, you discussed your relationship with Stephen Hawking, along with his warning that artificial intelligence could spell the end of the human race. Do you think that the current discussions of UAP, artificial intelligence, and the singularity may be offering us a glimpse of our own future and perhaps an opportunity to avoid mistakes that may have destroyed other civilizations?
Definitely. There is always a benefit knowing about reality, especially if you live on a street and you want to know what your neighbors went through because you share the same environment. And so the way I put it is we arrived relatively late to the cosmic play, only over the past few million years. We are not at the center of the stage. And so the play is not about us. And we better seek other actors who spend more time and figure out what the play is about. And another way to think of it is we better go out and check what our neighbors know already and then learn from their mistakes, learn from their wisdom, because one can think of natural selection in interstellar space. Those that survive are the ones that are more intelligent because they realize what is required for them to have a long-term future. It's avoiding conflicts on the rock that they were born on. And if you look at us, we are investing most of our resources in military budgets and conflicts. So that is not a sign of intelligence. And perhaps we would be inspired to do better That's my hope, because if we were to allocate all the $2 trillion a year that we spend on military budgets worldwide to space exploration, we could send a probe towards every star in the Milky Way galaxy within this century. I did the calculation, and that means that someone else that decided to explore space could have done it many times over. And that's the kind of inspiration we may get from opening a letter in our mailbox from that someone.
It's just incredible. It is incredible. Last but not least, I want to touch on the Galileo Project. You've had an amazingly busy year so far. I wanted to ask if you have any updates for us on how the project is coming along since we last spoke.
Yeah, so it's making very significant progress, in the sense that we have an operating observatory at Harvard University right now, looking at the sky 24/7, and I keep asking the postdocs to let me know if they see anything anomalous. And so far, we can identify all the objects we see, but we proved the method of using infrared cameras, optical camera, a zoom camera, also radio passive radar system, and the audio system to monitor the sky. And we already are assembling a second copy of this observatory in Colorado, and we plan to make more copies depending on how much funding we have. So we are demonstrating that we can control instruments and monitor the sky systematically, so we understand the background of objects that are out there. And the NASA is releasing a study where I expect them to recommend exactly the same thing. We've been doing it already for a couple of years, and on this I would say what Oscar Wilde said, that imitation is the sincerest form of flattery. And we hope that more scientists will get engaged, and that we will get to the bottom of what these unidentified anomalous phenomena are. And we don't need to wait for the government to tell us, because the sky is not classified.
Avi, let me thank you so much for your time. Again, it is always a pleasure and truly an honor to have you on and to help educate our audience. Let me close by asking how the public can help to support the Galileo Project, and also where we can anticipate seeing you in future headlines.
So we have a support us button on the Galileo Project website, or if you just put in Google Galileo Project.space.com, you would find how to support us. Any large donation could be addressed to me, and I will connect the donor to the relevant channel for us to receive that donation. We really rely on private donations, because this subject is not supported by federal agencies as of now. And we are dedicated to working 24/7 on this if funding is available. And of course, the next milestone with respect to the expedition, where we already have results, is the search for bigger pieces. And we're planning to do it within a year. For updates about the research, you can just check Avi Loeb at medium.com, where I describe the latest in my essays, but also on my professional website at Harvard University, you can find more details. And altogether, I'm quite confident that the next year or two will be very exciting.
Wonderful. Thank you again so much for your time today, sir.
Thanks for having me.